Hey everybody, and welcome to Unit 2, Section 1. Today we are going to be talking about algebraic proofs. So the learning target is, I can construct an algebraic proof using algebraic properties of equality. And I got a nice little math joke there. What did 0 say to 8? Hey, nice belt. If you don't get it, then stay on that slide a little bit longer till you do get it, because it's a funny joke. So let's think about some basic algebra here. What is the value of x? And justify each step. Now this word justify simply means explain it. Why could you do that? So on the left side here, we have 3x minus 9 equals 0. Well, the first thing we would do is add 9 to both sides. So on the left side, we have 3x, and on the right side now we have 9. Then we would divide to try to get x by itself. So we divide both sides by 3. So x is 3. The thing we did on this step, let me change my color. Here, we added. And then here, we divided. The one on the right-hand side looks a little bit more complicated, but is not beyond our capabilities. We have 12 minus x equals x over 5. Uh-oh. Well, the thing that scares me the most is this fraction. So I want to get rid of that denominator first. In order to do that, we have to multiply by that denominator to get everything out of it. So then on the right-hand side, that cancels out the denominator, so we just have x on the right-hand side. But if we are multiplying everything on the left-hand side by 5 as well, we need to distribute that. 5 times 12 is 60. 5 times negative x is negative 5x. And then if we want to try to solve for the variable, we need to get all of our x's on the same side. So I would probably put them all on the right-hand side because I'm a positive person, so I like to try to keep things positive. Add 5x to both sides, so it cancels it out there. On the left-hand side, we have 60. On the right-hand side, we have 1x plus 5x, which is 6x. Then we divide both sides by 6. And x equals 10. So to recap on those steps, we multiplied, and I'm running out of a little room there. Then we added, and then we divided. You have spent years of your math life learning how to do the algebra. So the stuff that's in red and purple, the things that we went through first. The new component, what makes this important, is the justify. That's a really important thing for today. Let's kind of explain this. So justifying steps, which is also known as a proof. A proof is a step-by-step argument that begins with known facts, contains logical deductions, and ends with the thing you were asked to prove. So some big words in there. Arguments. So you are going through a thought process and you are defending why you are doing each thing. These logical deductions, so logical means it follows a rule, something that's been set in place. You're not just pulling things out of thin air. And deductions are conclusions that you can come to. When you think about The task 1 for today, you were doing some deductions. You were drawing conclusions based on logic. And then in proofs, the end game, which we will get to later, is you have a destination that you are trying to get to, that thing you are trying to prove. That's where you end in a formal proof. Throughout this school year, we will develop many tools to help us justify, there's that word again, a wide variety of deductions. So of conclusions you could make, of statements you could make. These tools are the reasons why we can make the claims that we do. I like to think of it as a lawyer in a courtroom, and you have a whole bunch of evidence and you are trying to prove that your client is innocent. So what you need to do is you need to walk through that evidence and explain how this all makes your client innocent. I think it's really fun stuff. Hopefully you agree. Let's start by building some of these rules that you already know. These rules are the algebraic properties of equality. It's basic math. So we've got this rule of addition. If A equals B, then A plus C equals B plus C. If we think of our balanced scale, so if we have two things that are equal, and we add the same thing to both sides, it'll stay balanced. So here's an example. If I said that x equaled 3, and I added 2 to both sides, x plus 2 should equal 3 plus 2, or 5. Is this a true statement? Let's erase a little bit of this to clean it up. If I'm telling you x equals 3, I'm telling you it does, then would x plus 2 equal 5? Yeah, because we could go 3 plus 2 equals 5. We got the same idea working for us with subtraction. If A equals B, if we have two things that are equal to each other, then we can subtract the same term from both sides and it'll stay equal. So let's say we have the letter M equals 12. And if I subtract the same thing from both sides, this will still stay an equal statement. M minus 1 equals 12 minus 1, and 12 minus 1 is 11. So is that still a true statement? Does M minus 1 equal 11? It does if we said that M equaled 12. You've already been using these tools to solve algebraic equations. You've already been using it to help simplify things. Now we're just putting names to it because we want to explain this to somebody else. We want to justify how we can do the mathematical things that we're doing. It doesn't just work for addition and subtraction, it also works for multiplication and division. If I have A equals B, then A times something equals B times that same thing. So if I say x equals 7, then 2x equals 14 is true because I'm multiplying both sides by 2. Let's see if I can get a good color that will distinguish here. If I'm multiplying both sides by 2 by the same thing, 2 times x is 2x, 2 times 7 is 14. 2x equals 14. Well, if x was already 7, plug that in. 14 is 14. That's true. And if it works for multiplication, it works for division almost all the time. And there's one key instance where this doesn't work. So for division, if A equals B and C does not equal 0, then we can divide both sides by the same thing and it stays balanced. So if I have the letter P equals 4, I can divide both sides by 2. So then P over 2 equals 4. This works if we have one variable. It works if we have 5. It works if we have just numbers. I mean, I think we all could agree that the number 10 equals the number 10. So if I divide both of those by 5, it better stay equal. Well, the left side, 10 divided by 5 is 2. The right side, 10 divided by 5 is 2. It stays equal.